Hey, welcome back to Math with Patrick and Quill. Today is December 25th, and we're solving problem 359 from the Daily Epsilon calendar. The answer today should be 25 because that's today's date. So we need to find the volume of a shape. It's bounded by four different inequalities. These ones just give me basically a domain, range, and whatever you call it for the z variable. And then this one should look like a plane in 3D space, and that will help bound our shape as well. Let's just target this part first. Here, I'm going to draw the pretty standard 3D axes. Let's put X and Z right here, and I'm going to shove Y into the page like this. One way to remember is that your thumb, index finger, and middle finger, on your right hand specifically, can help define the positive X, Y, and Z axes respectively, and then usually I stick the middle finger up. And then X to my right, and then Y to my forwards. And here we can label X going from 0 to 5. I think I'll just plot my endpoints. So there will be 0, there will be 5. I'll do the same for Y, 0, and then 5. Let me build this box right here, or I guess this square, technically, as this is going to also be part of my viable domain, my viable numbers here. And then Z is going to go from 0 to 6. So I'll try to make my rectangular prism a little bit taller than it is wide or long. But honestly, it's just a sketch, so it's all right if I mess up a little bit. Anyways, this box that I'm drawing does have a 5 by 5 base, and then it has a height of 6. And I think before I even worry about my, oops, that one doesn't quite land, so no worries there. I might just move the point over and fix my sketch. um, I want to find the volume of this box first, just because I feel like that'll be useful for the answer. Volumes of prisms, rectangular prisms is very easy. You just multiply the 3 dimensions. The idea being is that we're finding the area of the base, and then we're multiplying the base by the height that we have. So the volume of our box is going to be base times height, or 5 times 5 times 6. And seeing that today's the 25th, I am going to just keep it as 25 times 6 and hold it there. And I think this 25 will turn into my answer. Let's finally draw what this last inequality is going to tell us on the page. Maybe I'll use a different color. So this inequality is in standard form, I would say, where all of our variables and coefficients are on one side, and we just have some number on the right side. And this is very useful because if we plug in zeros for 2 of our 3 variables, we can very quickly get the last variable, and plotting some points, 3 points, will help us define a plane. So if I'm imagining that x and y are 0, I only have the inequality 5z is less than or equal to 30, and z equaling 6 is great, and anything less than 6 is also okay. And I'm noticing that it lines up quite nicely with the inequalities that we were already given. So I do know a valid point on this plane is going to be 0, 0, and then 6. Using the same reasoning, I could set x and z equal to 0. This shows that y being 5 is totally valid, and also any numbers less than 5 should be fine. And then, same idea, I can get the point 5, 0, 0. So on my 3D graph, 0, 0, 6 should be this point right here. 0, 5, 0 is this one, and then 5, 0, 0 is that one. And I can connect all 3 of these points in a plane. And so this is the shape that we're trying to find the volume of. We can use maybe the x-axis, the z-axis, the x-axis, and the y-axis as some of our edges. And then the plane helps draw out the other 3 here. So what I'm seeing from this is a triangular pyramid. We have a triangle base, and it's a pyramid because all of these 3 sides come up to 1 point. The volume of a pyramid is always 1/3 of the prism that it's inside. And I'm not actually going to choose the whole rectangular prism. It's actually better to choose the prism that relates to the base of the pyramid. And in this case, we do have a triangular prism. So I need to find the volume of this prism right here, and then take 1/3 of it, because again, any pyramid is always going to have 1/3 of the volume of the prism that it's in. What's kind of cool is that we could move this point, say somewhere in the middle here, and make all of these edges kind of attach towards this middle point. And as long as this point has the same height as the other one that we're working with today, that pyramid also has the same volume. Kind of cool. Anyways, the purple prism that I drew out here is just half of the whole rectangular prism that we were working with. So I could just divide by 2. And then now I could divide by 3, because that's the same thing as multiplying by that 1/3. And just as I suspected, that 25 was hiding here all along. That was our answer, because the 1/3 that we used for the pyramid idea and the half that we used because our base was half of the whole base here, both of those canceled with that 6. The 6 was the 6 that we got from the height here. So kind of interestingly, the volume of our triangular pyramid has the same, at least numerical value, as the base of our rectangular pyramid. And that 25 is going to be our answer. So that's about it. Some neat facts about pyramids, some nice 3D graphing, and some neat inequalities to solve the problem for today. So I think we're all done. Thank you for watching, and I'll see you tomorrow. Bye.